All right. Let's talk about graphs of, how do we if we change the input for the sine function as a multiple of x, how does the graph behave?
So I put on the screen here, this is just regular plain vanilla y equals sine x.
Sure.
We know it goes up to 1, we know it goes down to -1, and we know that the wavelength is 2 pi.
Yes.
So I'm going to, just so I can draw on it, I'm going to grab a clip here of it. And so let me just write what we said here. We know that this 0 is 2 pi for the regular.
Yes.
And then this must be halfway back.
Yeah.
So that must be pi.
Yeah.
So I'm going to concentrate on this point here.
Sure.
That's 0, 0. That's pi 0.
Okay.
So I guess if let's put a 2 in front of here.
Sure.
So I'm gonna think about the graph now. It's not just sine x. I'm gonna write clumsily write y equals sine 2x. So we're gonna make the argument that I put a 2 in front of the x. The y is still like the sine of something.
Sure.
So the biggest a sine could ever be is 1. The smallest a sine could ever be is -1. So it still goes
Makes
up
sense.
to 1 and down to -1.
Yep, absolutely makes sense.
My initial intuition is throwing a 2 in front of here should like stretch it this way.
That sounds right? Let's see what happens. So let's focus on that pi. X is equal to pi, right there, right? So if I'm looking at y is equal to 2 sine 2x, and I want that point, I want 2x to be equal to pi.
Because last time we took the sine of pi and got 0.
0, exactly.
Now we're taking the sine of
2x to be sine 2x to be pi, so I get sine pi to be 0. So from there I get x is equal to pi over 2. So that point for the new graph is going to be pi over 2.
So like the symmetry, that makes this pi over 2, that must make this pi.
Yeah, exactly.
Okay.
Yeah.
So my intuition was wrong.
Yeah, well, yes, a little bit, sorry. No, but I can see why, we multiplying everything by 2, so why not think about it stretching out? But it's kind of shrinking a little bit.
So a normal, like going back to the original wavelength, the original wavelength was 2 pi.
Yes.
And now the original wavelength is pi.
Pi. So that means if I'm starting on the x-axis, going counterclockwise on the unit circle, I only got to 180 degrees.
So let me catch up with you. So
Yeah.
you got to here
Exactly.
before you got through a full wavelength.
Full wavelength.
So there's still another bottom half of the unit circle.
Exactly. But that's going to look like exactly like that first two pieces, right? From 0 to pi. It just has one more of that.
So I got one wave in the top of the circle and a second wave in the bottom of the circle.
Exactly.
So normally I would get one wave per revolution of the circle.
Exactly.
And now we put a 2 in front and we got two waves
for one circle.
for one circle.
Yeah.
So this coefficient of 2, it's giving me the number of waves per circle.
Exactly. Yeah, we can think about that way. Yeah. So here is a question. So what if I change that instead of 2x, what if I'm interested in kx for any constant? K?
Okay, so I'm going to throw a k in front. Now let's do what you did before.
Sure.
This was on a normal sine graph, a plain vanilla sine graph. This was pi.
Yes.
So the argument was pi, the angle was pi. But now I've got the kx is going to be equal to pi. And so solving, now I'm getting that x value. This first 0 point is pi over k.
Yes. So in the previous case, k was 2, so that's why we got pi over 2 for x.
But now it works for any number
Any,
k.
any value k, yeah.
So this point here is pi over k.
Yeah,
So now that means this point here would be twice that, right? So
Yes.
this other point would be, that would be
2 pi over
2 pi over k.
Yeah,
Oh, and 2 pi is one revolution of
Exactly.
a circle.
Yeah.
So I'm dividing it by k. So if k was, let's say, 8,
yeah,
each wavelength would be 2 pi over 8, would be one circle over 8,
yeah.
an eighth of a circle. So I would get 8
8
in there.
8, yeah,
So from what you're saying then, that k in front, that's just equal to the number of wavelengths
per circle.
per circle.
Yeah,
Okay, that's cool.
yeah, yeah. But not to make things more complicated, we've been saying k, we said 2, we said 8. What if k is a fraction?
Okay,
For,
so
for
I'm
example,
gonna-
1/2.
So I'm going to go put, now I could go 1/2 times x, or
Sure.
you might see that as
X
that.
over- yeah.
But I'm still making k being a half. So
Yes.
I'm just going to throw a half in there 'cause to follow what we did
Sure,
before.
sure.
And when I cross multiply that up, that's going to be 2
2
pi. So that means this point here
Yeah,
is
it's
2
2
pi.
pi.
That's already a circle.
Already a circle.
So this one hump of sine
Mhm.
takes a whole circle.
Circle, yeah. So to get my full sine wave, I need twice around the circle.
So 2 revolutions of a circle to give me one hump, then 2 hump,
Yeah.
one full sine.
Yeah.
So then the wavelength is like twice as long
Twice as long, yeah, yeah. And so I think the idea is like, so if k, the constant we multiplied, if that is bigger than or equal to 1, we can think about it being kind of shrinking. You
So
have multiple-
compressing it this way,
Yeah.
because you're trying to squeeze more wavelengths
Yeah.
in the 2 pi.
Yeah, and if it is between, if it is less than 1, or is, between, minus 1 and 1, then you kind of stretching it out a little bit.
So I'm just repeating what you're saying so
Yeah.
I get it. So if it's a fraction, that means that you're only getting a fraction of a wavelength per
Exactly,
circle.
exactly.
So you have to go through more circles to
Yeah.
get a full wavelength.
Yeah.
So it looks like you stretched it out this way.
Yeah.
Because I have to go through more
Multiple- yeah,
circles
yeah.
to get through.
Yeah,
Okay.
exactly, yeah.
So altering the wavelength then is just this, go back to just in general so I can reiterate it to
Yeah.
myself here. So if I have sine equals kx,
Uh-huh.
then kx, this is always 0, 0.
Yes.
The next 0 point should be pi over 2.
Uh-huh.
So I can set that kx equal to pi over 2
Uh-huh.
and figure out what the x value has to be here.
Yeah. Oh, no, pi, right?
Pi, yeah, my bad. Yeah, pi, you're right. So then that makes that x is equal to the pi over k.
K, yeah.
That's that next over k.
Yeah.
That's that next 0.
Yes,
And this
exactly.
would be 2 pi over k
Yeah.
because it's like one hump
Yeah.
and then the other hump.
Yep, yep, yep.
So that's this value here
Yeah.
is pi over k.
Pi over k.
And k, if someone asks me, what does k mean? I can say k is the number of wavelengths
Yep,
per revolution
per
of the
revolution.
unit circle.
Exactly.
Okay,
Yeah.
I think I get it.
Yeah, yeah, that's good.